Linear programming word problems. We've got 7 steps to write down, and then we're going to do one example. There will not be any homework tonight. We'll do the homework in class tomorrow. So when we have a linear programming word problem, step 1 is going to be define your variables. So we're going to have a paragraph long problem. We're going to need to try to tear it apart. So step 1 is define your variables. So inevitably it's going to be x equals y equals. So we're talking about I don't know, sales at a vending booth, hot dogs and hamburgers. X is hot dogs, y is hamburgers. Okay. We're going to go through. We're just going to define our variables. Tell the reader what does x represent, what does y represent. Step 2 is to write an objective function. Write an objective function. Remember, your objective is your goal, what you're trying to accomplish. This will always be an equation. Okay, so if your objective is to make the most money, it's going to be profit equals. If your profit is $182, okay, it's going to always be an equation. Step 3 is to identify and write your constraints. So step 3 is identify and write constraint inequalities.
Did you say what that's right?
It's probably going to push back there too. We're going to work on this today, tomorrow. Probably do this also on Wednesday. The test will be Thursday or Friday. Step 3 is identify and write constraint inequalities. Key word there is inequalities. These will always be less than or greater than statements. Now, once you've written all of your constraints, we can then take all those inequalities and put them on the same graph. And when we do that, we create, what's that called? Good. We create the feasible region. Okay? So, graph the feasible region. Graph the feasible region. So we're going to have some kind of geometrical figure, whether that might be a triangle, a quadrilateral, or any kind of unbounded polygon if it goes on forever. An example of cost. Cost is unbounded. So you're going to graph the feasible region. Step 5 is to label and identify all vertices. When you create your feasible region, it's going to be some kind of geometrical shape. All geometrical polygons have vertices. The edges of the polygon are conjoined at a vertex. So label the vertices and then identify all of them. So find where they happen at. Now when you do that, one of those vertices is going to give you the optimal answer. One of them is going to give you the best answer, one of them is going to give you the worst answer. So number 6 is identify which vertex is the optimal solution. For your objective. So if we look at this, step 1 is to identify your variables. Tell what x is, tell what y is. Step 2 is to write an objective function. That's your equation. That's what your goal is. Once you've done step 2, you don't refer back to it for a while. Once you've written your objective function, you kind of just set it aside. You leave it alone. Step 3, identify and write the constraints. Step 4, graph the feasible region. Step 5 is label and identify all the vertices. And then step 6, identify which vertex is the optimal solution for your objective. So then you're going to take these vertices that you found in number 5 and plug them into the equation that you wrote in number 2. So after we get here, we're going to reuse this step. And then step 7 is to write a conclusionary sentence, a conclusionary statement. Write a conclusionary statement. So, in the previous, or on Friday, we wrote the maximum value of p equal 3x plus 5y is 12, and this occurred at 0, 4. The difference would be we'd write a conclusionary statement for this section as the maximum profit is $12, and this occurs by selling 4 hot dogs and 0 hamburgers, whatever it may be. So we write a conclusionary statement. Here's the first and only example we'll do today. Yep.
You got a lot, you don't need a lot of it.
I would go ahead and put your example on the back of the page that we just wrote, because it's going to take 2 sheets of paper. But it is for me at least. I mean, if you write small, I'd put it over here, and then that way we can work it out on, and it'll all be in the same area. Okay, so here's the problem. Here's the example. A farmer has 162 acres of land.
You don't wonder where this came from.
The farmer has 162 acres of land. He wants to plant beans and corn. It costs $40 per acre to plant beans. Which yielded a profit of $250 per acre. It costs 60 per acre to plant corn. Which yields a profit of $300 per acre. He has $8,600 to spend. How many acres of each? Should he plant to maximize profit? It's the scenario at hand problem we did at the beginning of the chapter. Everything we've done in the chapter leads up to being able to do word problems. That can be, this concept can be applied in any business setting. We're doing just 2 variables, but the same concept applies to even 3 variables. Farmer has 162 acres of land. He wants to plant beans and corn. $40 to plant beans. Profit $250 an acre. $60 per acre to plant corn. It yields a profit of $300. He has $8,600 to spend. How many acres of each should he plant to maximize his profit? Going through these in steps. Step 1 is to identify your variables. X equals Y equals. And step 2 is to write an objective function. Your objective function is your goal. The goal of the problem is always found in the very last sentence of the problem. It says how many acres of each should he plant to maximize profit. So what's the goal? We're trying to maximize profit. So in doing step 2, we're going to put profit equals. Profit equals Okay, the goal is profit. Now we read up through the problem, and well, what affects this profit? What's the variables that affect this profit? X and Y, but what does X and Y represent? Corn and beans. It doesn't matter which one you define. Just for the sake of everyone being on the same page, I'm going to put X, make sure you put X as beans and Y as corn. The only reason I've done that is because beans is listed first when you read the problem. So X is beans, Y is corn. It does not matter though. Now we're talking about profit. So we need to read through the problem and we need to identify any numerical value that deals with profit. It costs $40 an acre to plant beans, which yields a profit of $250 an acre. So reading that sentence, what's the numerical value we're going to use? Profit of $250. And then the corn, we do profit of $300. I'm putting these all in pink because that way you can see that they're all related to each other. Profit, profit, and profit. So we're going to write an equation. What's the equation? 250x plus 300y. Good. So step one, identify your variables, which are what affects his objective, the goal. Step two is write the objective function, which in this case is profit. Here's our two pieces of information in the problem that deal with profit, so we use those. Step three is your constraints. We have two constraints. We have land and money to spend. These are constraints. He only has so much land. He only has so much money to spend. I'm going to highlight land in, or money to, it doesn't matter, land in blue. Looking up through the problem, where's the only statement that deals with land? The first one. He has 162 acres of land. How do we write that as an equation, inequality? X plus Y, beans plus corn, have to be less than or equal to 162. Now money to spend. Okay, so everything that is in this inequality has to deal with money spent. He has $8,600 to spend. It costs $40 per acre for beans and $60 per acre for corn. So all of that information has to be put into, we can think of this as a cost inequality. How do we write it?
40x plus 60y.
Good.
It's less 8,600.
40x plus 60y is less than or equal to 8,600. Now there's two other constraints that are not listed in the problem. It says, the second part says he wants to plant beans and corn. Okay, so, this second sentence is what gives us what our variables are. We've used the cost, we've used the profit, we've used the cost of corn, the profit of corn, we've used the total money spent, and we've identified what the objective is from the question at the end. So we've used every single sentence in this problem has been used at some point in time. So, but there's still two objectives. If you're talking about a real world problem, you're talking about planting corn and planting beans, what kind of acreage can you not plant? Think about the XY axis. If we graph these equations, you can't plant negative. Okay, so the amount of corn that we plant has to be more than or equal to 0, and the amount of beans that we have to plant have to be more than or equal to 0. So it's not given to us, but it should be implied. These will always be included in your constraints. These are always implied. These always need to be listed. You cannot have negative corn, you cannot have negative beans. So X and Y both have to be more than or equal to 0. All right. Step 4 is to draw a graph the constraints. So, since we've said we're never going to have negative x or negative y value, to draw this graph, we can actually just draw a picture of the first quadrant. We don't need to draw the entire xy axis. Just the first quadrant is sufficient. We need to graph each of these inequalities. So, looking at x plus y is less than or equal to 62. What form is it in? Standard form. So to graph standard form, we need to know the x-intercept and the y-intercept. The convenience about this problem is since they both have a coefficient of 1, the x-intercept and the y-intercept is both what? 162. If you plug 0 in for either variable, the other variable is going to be 162. Now we don't want to put 162 tick marks, so we're just going to put a tick mark on the y, tick mark on the x, the x-axis, and we're going to connect them. I'm going to go ahead and write x plus y equals 162. That would be important for later on. We're going to be graphing several lines in the same graph, so sometimes writing the equation beside them will be helpful later on. And then we need to shade either below or above. We plug the origin in. Is 0 plus 0 less than or equal to 162? That's true. So we shade below or above? Below. So I'm going to just put a B here. Below. Okay. It's not something you have to do, but it should be a mental note. I need to shade below. Now the next inequality. 40x plus 60y is less than or equal to 8600. It's in standard form. We're going to use the intercepts. The x-intercept, we plug 0 in for y. 60y goes away. We divide the 40 over. Does anybody have that? Guys, this is a math class. Add it to your to-do list. Put a calculator on the desk. $215. The y-intercept, anybody? $143.33. Okay, now we're talking about real world problems, so that's okay to have a decimal. We also write it as 143 1/3, right? Now in terms of a real world problem, having a mixed number is appropriate. Okay, I know at the beginning when we did fractions, I said we always use improper, but 143 1/3 acres makes a lot more sense than 670 over 3 acres. Okay, so mixed numbers make more sense than the real world problems. So what we'll do is here we'll just put a 215 on the x, 143 1/3 on the y, and we'll connect those two with a straight line. That's a pretty straight line. And this is the equation of 40x plus 60y equals 8600. We're going to plug the origin in. 40 times 0 is 0. 60 times 0 is 0. So we get 0 is less than or equal to 8600. True or false? True. So do we shade below or above? Below. So we've got to shade below both of these. Okay, so our combined region is everything over here. Now, but the last two constraints that were not in the problem but are implied, x is greater than or equal to 0, y is greater than or equal to 0, just says we have to be in the first quadrant. X is greater than or equal to 0 is a vertical line at the origin, and we shade to the, what, left or right? To the right. Y is greater than or equal to 0 is a horizontal line at the origin. And do we shade above or below it? Above. So these two just say we're in the first quadrant. And the only overlap of these four is this quadrilateral. The only area that we are in the first quadrant and below both lines is in that shaded region. I'm just going to copy the picture over the next page. You don't have to unless you want to. I'm just copying the same picture. Okay, so we've graphed our feasible region. That was step 4. Step 5 is to label and identify the vertices. How you label them is up to you. I'm going to label them as such. I'm going to call this one A. The origin will be B. Over here will be C. And then the one that's out in the middle of quadrant 1 will be D. How you label them is up to you. Everyone could have them labeled differently. You can label them W, X, Y, Z. It does not matter. You just have to label them. Triangle, square, rectangle, plus sign. Okay? It does not matter how you label them. You just have to label them and find them. So we need to figure out where A is, B is, C, and D. I labeled mine in that order just because A, B, and C we know without doing any work. What's the ordered pair of A? 0 and 143 and 1/3. B we know is 0, 0, and C is 162, 0. D has to be calculated. We've definitely not drawn this picture to scale. There's no way to look at tick marks and know the answer to where these two cross. So we have to say what two equations create D. And that's the equations x plus y equals 162 and 40x plus 60y equals 8600. So the solution of this is just going to be where the farmer has spent all of his money and all of his land. If you look at C, he spent all of his land, but has he spent all of his money? No. A is he spent all of his money, but he's not spent all of his land. He's got land left over. Okay. B is he spent nothing on either or. And then D is the intersection where he spent all of his land, because this is the land inequality, and all of his money. We can solve this with substitution or elimination. Elimination is usually the best. I'd multiply it by -40. Multiply the top one by -40. We get -40x, -40y, and I think this is -6,480. We only need to manipulate the first one. We don't have to manipulate the second one. 40 and -40 eliminate. 60 and -40 make 20. And then 8,600 and -6,480. 2,120. And then we do what? Divide by 20. And then here's the convenience, guys. Look, the zeros cancel. What's half of 212? 106. And then we can plug it back into either equation. The first equation is the easiest. It says he has to have a total of 162 acres. So if he has 106 of the one, he has to have a total of 56 of the other. So now we know D is at 56, 106. Those numbers should sound familiar. Okay, that's the answer. That's the optimal answer we got when we did it through the guess and check. Or a lot of you did it through guess and check at the beginning of this chapter. Step 6 is to plug the vertices into the objective to find the optimal answer. So we're going to go back to our profit equation. That's our objective function. 250x plus 300y. And we're going to find out what's the profit of vertex A. What's the profit of vertex B? What's the profit of C? And what's the profit of D? Now, obviously, guys, profit of vertex B is kind of redundant, right? If you plant 0 corn and 0 beans, obviously the profit's going to be 0. But just for the sake of showing that we understand the concept, we plug those 4 vertices into into the profit equation. A, I think, was at 0, 143.33. So we're just going to plug that in. 0 plus 300 times 143.33. Anybody? 42,999. Does it have a decimal at all?
Yeah, between 42.
Well, that's a comma, right? That's okay. But there's nothing after the 999?
No.
Okay. Profit of B, I already said this. You wouldn't necessarily even need to write this out. If you plug in 0, 0, you get 0. Profit of C. $250 times 162. What is it?
400.
40,500. $40,500. So of A and C, what's the better? A. So you're better off to plant 143 acres of corn. So you're better off to use all of your money, but not all of your land, than you are to use all of your land and not all of your money. And then doing both of them, 56 and 106, gives us, I think it's 45,800. 45,800, which is the answer we got when we did it at the beginning of the chapter. So we've identified the optimal answer. And then step 7 is to write a conclusionary statement. So to reach a max profit, to reach a maximum profit of 45,800. And in terms of just the problem that were given to us, we said this occurs at this ordered pair. We don't say this occurs at 56, 106. 56 and 106 represent a scenario. We'd say to reach a max profit of 45,800, the farmer must plant the 56 represents 56 what? Acres of beans. And 106 acres of corn. Okay. We actually interpret it in context to the problem. We give a conclusionary statement in context to the problem. All right. That is the end of the notes. No homework tonight. So you got the next 6 minutes to just chit chat amongst yourselves. Can you walk?
Give your toilet paper.
Yeah, you are. You're missing the farmer part there. The one that you were here for. I said, there you are.
Yeah.
Tell her that she
Figure it out.
It's not exactly wrong. But you can do that.
So I can pretty much do it just like guess and check. A lot of people.
That's what you're missing.
Okay.
Yeah, let's go. Guys, I don't care if you talk, just have a seat. I don't care if you talk, just have a seat.